Okay, I'm going to look at volume today, looking specifically at the volume of a prism. Just some basics before I just start here. What is volume? Well, volume is the amount of space within a three-dimensional shape, and the basics of volume was counting in cubes. So if I take a cube on the board here, I'll make it 1 centimetre, obviously not to scale, and that is defined as having a volume of 1 centimetre cubed. And if you count up two of them put together, it starts to make 3D shapes, 2 centimetres cubed. Obviously, for familiar shapes, we can use formulas to find the volume. Okay, a prism. We're going to go, before I get to a prism, there's a special type of prism, which is a cuboid or cube. So if I draw on the board here, a cube, so a cuboid, like that. I'll just draw across there like that. There's a cuboid. Okay. Now that is defined as a prism because what a prism is, if I just get my red pen here, if you look at one of the faces here, and what we call, this is called the cross section. If you look at the other end of the shape, of the other end, I call this the tunnel by the way, so as you look through the tunnel, as you go to the end, I'll use dotted lines there to make it look a bit more like a 3D shape, and here as well there. You can see that the tunnel, or the cross section, repeats itself, i.e. is identical along that particular length there. Okay? And what the formula is for the volume of a prism, and this is a prism, and this is a rather special prism by the way, because I could actually cross-sect it from this face and it would be the same on the other side, or I could cross-sect it from above, from the top down to the base there. So there's 3 different ways I could do this. Now a prism is something which can be sliced into equal shapes called cross-sections. I call that the shape of the tunnel, okay, along one of its length. And provided that's from at least one face, if that's the same from one end to the other, then it's called a prism, provided it's got straight sides as well. So this here is the area of the cross section. So I'll put area there of the cross section. Okay, or I often call it the tunnel shape. And this is the length which it cross-sects along. In other words, it repeats itself across there. Now, if I call that the length, then this is the width of the cuboid and this is its height. So if you can find what we do, we find the area of the cross-section. Let me write the form on here. So the volume of a prism, it's a shortcut to counting all those cubes, is the area of the cross-section multiplied by, clearer, times by the length. Well, the area of the cross-section here, this is the area of the cross-section here, is going to be the area of a rectangle, is base times height. In this case it's width times height, which is like the base is the width, the height is the height. So that gives you that bit, which is here, the area of the cross-section. And then what you do when you've got all that, which is the area of the cross-section, you times it by the length, which is here. And it comes up with a formula which is, you can juggle those numbers around, you've got length, width and height. And then whether you cross-sect it from this face to the other side or downwards, you're always going to get length, width and height. 3 dimensions of the shape, its length, width and height, multiply together. So therefore, we can, for a special case, okay, for a special case, let's just get that here. What I can say now is here, that the volume of a cube is a cuboid, just all the lengths the same, stroke cuboid, is going to be length times width times height, which is what that formula is doing, but it's just a shortcut to that. Okay, so defined as a prism, as I summarise again, if it can be cross-sected from one length all the way along its length, the shape doesn't change, it stays the same, as the shape of the tunnel stays the same, then it is a prism. Okay, that's, as I said already, a special case of a prism. So, if I now look at a different type of prism, where that formula is going to get used, obviously length, width and height multiplied together is only valid for a cube or cuboid. So if I now make this as a prism, there's the length the tunnel's going to go along. So let's try and draw that parallel that way, make it a little bit more realistic. Oops. Higher than that. Okay. A little bit off there. There's a bit down there. Oops. Just draw that a bit better now. Come the wrong way there. That's better. Come the wrong way there. And there. And there. And there you can see the shape of the cross section. You can see that triangle. Okay, let's just use the blue pen here so you can see that. You can see that cross section there is the same along there. So if you go along that length there, then it doesn't change the shape of the tunnel, the cross section. So obviously you find the area of that, which happens to be a triangle, and then you times by the length. Okay, and this has got a name, it's called a triangular prism. So then the actual cross section usually gives the name to the prism. In this case it's a triangular prism. Let's put some numbers onto this. Let's say we've got 5 centimetres, 6 centimetres and 10 centimetres. Then what you've got to do there is, first of all, the formula I've got to use now is A times H. So let's do the A bit first, which is the area of the cross section, this bit. Because it's a triangle, the area of the triangle is base times height divided by 2. Remember, that bit there is the base. Let's put that in red. There's the base, and there's the height. And they must be, by the way, the height and the base must be perpendicular to each other, otherwise the formula is not correct. And the base there is 5 times the height there, which is 6, divided by 2. 5, 6 is 30, divided by 2 is 15, so 15 centimetres squared. And then what you do, you divide it into loads of blocks, and this is how the formula works, is that's a load of cubes being packed along this length along here. This is where the formula comes from. So therefore the volume of that triangular prism is the area of the cross section, this bit, which I've just worked out to be 15, multiplied by the length, which is 10, and that gives you 150 units, because its volume is centimetre cube. In other words, if that was drawn to full size, you would actually get 150 dies in that, dies packed inside that, which will fill up all the space of that. Okay, so really simple to find the volume prism. You can recognise it. All you've got to know is know the area of these cross sections or the shape of the tunnel, and just times it by the length. So just before I go to a second example, just move across there. Let's look at different cross sections or different shaped tunnels. Well, avoiding the cube and the cuboid, because we know we can shorten the formula to length times width times height. So different cross sections. Okay. Well, you could have as I've just done, you could have a triangle. Draw a triangle differently then. That could be the shape of the tunnel. There's the base. There's the height, which is perpendicular to it. Base times height divided by 2. But you could have a parallelogram as a cross section, which is like, I often call it a squash rectangle, which is the fancy word is actually shear, but we'll keep it called a squash rectangle. Now, that's the base, that's the height, and the actual, you should know that the area of a parallelogram is base times height. It's actually the same as the area of a rectangle, because if you cut that bit off here and put it onto the end there, it creates the same space and it produces a rectangle, hence the two are the same areas. Other common cross sections you could have is this one here, quadrilateral, 4-sided shape here. It's got a pair of parallel sides, which is a trapezium. If that's the base, for B for base, that's the other parallel lengths. So A and B are the two parallel lengths, B being the base, and this is the height here. Then the formula which you have to learn for your exam is A plus B times by the height and divided by 2. I tend to split that up using BIDMAS. Remember BIDMAS, B-I-D-M-A-S. Do the brackets first, A plus B. Okay, and then you can either times by H or divide by 2. Actually, those two, like add and subtract, have equal priority. So I might go from there, times it by the height first, and then divide by 2. Or other way around, you can have them the other way around. And that was just a shortcut to be able to split the formula up. And then the other one is, you could have a prism with a circular cross section, which would actually be a cylinder. Actually, it follows the rules of a prism, but actually it's not classed as a prism because not all the sides are straight. Area of a full circle is going to be, I'll call it A equals pi r squared. Okay, pi is that number which is linked to circles 3.141, etc., etc. And that you can tell that's the correct formula because the word square in it means you're counting squares. That's the way of remembering it. Another way of remembering it is this: apple pies are squared. A lot of students tend to learn that way of doing it. So A for area, apple pie pies are squared, and that's just a way of remembering that formula. Okay, and the radius is in that formula, and always remember the radius is what you set your compass at to draw a circle. So if you're setting your compass at that distance, that's always the radius, distance from the centre to the outside of the circle, its circumference is always the same. So that's the basics. So if you've got prisms with those shapes, okay, all you've got to do is find the areas of those and just times by the length. Okay, a couple more examples quickly, and then I'll finish this tutorial today. Okay, another example. Let's do one with a trapezium as the cross section. So let's see if I can draw this better. There it is there. Let's go there, across there, and across there, and down here. And then we've got it. And you can see the trapezium at the back there. Try to put that in a different colour. There. Yeah. There. And you can see the cross section there is the same as the red there. I won't draw this very well there. If I put that in a different colour, red, you can see at the end of the, when it goes through the tunnel, at the end of the tunnel you've got the same shape still there. Okay? Alright, so you can see that coming through there. We'll just there, put that into there. Let's just put some numbers in. So let's say I've got that's 7 centimeters, that's 3 centimeters, and let's say the height is here. Let's call that 4 centimeters, and then let's call this 20 centimeters. Okay, well there's your area of your cross section. There's the A bit, and there's the length the tunnel goes along L. And all you're going to use is the formula V equals A times L. So let's do A first. Well, we know it's a trapezium, pair of parallel sides, half A plus B times H. Right, we'll do the A plus B first. So before I was falling bid mass. A and B, 3 plus 7 is going to give you 10. Then you're going to times by that height, so you've got 10 already. So that's going to give you 10 times the height is 4. There's the height 4, which gives you 40. And the last part of the formula there is to divide it by 2. So you've now got 40 divided by 2, which gives you 20 centimetres squared. Sometimes in the exam they often give you this slant height here, and students seem to think, oh, I've got to use it. Well, if it's not part of the formula, then don't use it. And obviously that slant height was given there, and you wouldn't use that number. Obviously, it could be more complex situations where you've got the height. You're not given the height, you're given the slant height. You have to use Pythagoras to get the height. But obviously, that slant height does not come into the formula, so don't feel you've got to use every number given to try and catch you out on that. And then, obviously, the length of your cross section is 20. So there's the volume. The area of the cross section I've just worked out is 20 times by the length, which is 20. There, it has to be 20 again. 2 2s are 4, add the 2 noughts on is the same as multiplying by 10 and 10, 100, gives you 400 centimetres squared. Done. And then one example, I'll bring the one in with a circle. So, I just remove that. And let's look at a cylinder. So let's draw it upright, so like that. There, I'll do a dotted line there. Okay, so it's the same, call that 8 centimetres, and we'll call this distance across here 5 centimetres. Now we can see it's a prism. I'll just show you colour pens again. If you look there, that circle repeats itself across all the way through to the end there. If you've got a circle inside there, you can see there's another circle here. There's loads of circles there, and they're all repeating themselves down the line there. So all you've got to do is find the area of this cross section or the shape of the tunnel, and then times by its length again. So it's just knowing the area of the front bit, the cross section. Or if you look down on a plan view of that from above, you'd see this circle, okay, and the distance 5 is right across. Done that. Okay. Now we know the area of a full circle, apple pi r squared, is that. Now, I've already said to you that the radius is what you set your compass at to draw the circle. Now you can see that it's 2 radiuses across, which is actually the diameter of the circle. So the radius is obviously half of that, 5 divided by 2, which is 2.5 centimetres. So to get that, you've got pi times r, which is 2.5 squared. Now that's going to give you a particularly nasty number on the calculator, which if you tap into the calculator, just leave it on your calculator screen. I'm just going to leave it like that because I'm not finished the calculation, and that's not a nice number. Now obviously the volume of a prism is the area of the cross section times by the length. The area of the cross section I just worked out is pi times 2.5 squared. I've left that, well that's stored in my calculator under not a nice number, times by the length it goes along, which is 8, and then you put all that into your calculator using the pi key for your calculator. Now if I've done that right here, I should, or you should have, 157.1, and that I've rounded to the nearest tenth or 1 decimal place to 1 dp. And that basically includes just a general understanding of volumes of prisms, all the basic things you could have at Key Stage 3 and certainly your GCSE exam. One other thing often sometimes comes, I'll just finish on this one here, sometimes you might have to put your volume in terms of litres, in terms of litres or centilitres. So 1 litre, you should know, is 1,000 centimetre cubed. And I have a little way of getting the ratio. A lot of ratios or a lot of conversions always start with 1 to something, and obviously 2 litres are 2,000, 3 litres are 3,000 centimetre cubed. So there's a little rule there, you can times by 1,000. Always go from the one bit to the other side, times by the other number. So to change from litres to centimetre cubed, you'd have to times by 1,000. So for example, if your volume came out, let's take the example there, let's say they wanted that in litres. So what you'd have to do from there, okay, you'd have to say, right, then now the volume, now obviously you've got the answer from there, but they just want on the answer bar, on the answer line in litres. So you do 157.1, or leave all the numbers on the calculator and round it up at the very end. I always say to students, round up at the very end, and then you've got full accuracy in your answer. So obviously to go from centimetre cubed, reverse the arrow to litres, you divide that by 1,000, okay, and you get, well, my numbers I've got there, I've got 0.571 litres, etc. there on that, and you round it to whatever you want, but I'll probably leave all the figures on the calculator and then divide it by 1,000. I think that really covers all the basics of volumes of prisms, the understanding of volume, and hopefully you'll be able to take that forward and do lots of exam questions and get better. Thank you very much.